GPUGraphX is a GPU-aided distributed graph processing system based on GraphX, which is built on top of Apache Spark. GPUGraphX follows the pre-JAWS-like framework of GraphX with GPU as the computation unit. In general, the system consists of three layers, namely GraphX layer, bridge layer and computation layer. This structure guarantees the efficiency of our system. Now we show you how to use GPUGraphX to run graph algorithms through GPU. To run graph algorithm on GPUGraphX, some interfaces need to be implemented, including pre-JAWS-like interface for GraphX layer, data transfer interface for bridge layer and CUDA-based computing interfaces for computation layer. It should be noted that the original GraphX also needs to implement the pre-JAWS-like interfaces, and the interfaces of the two systems are exactly the same. In the demonstration, we run the single-source shortest path algorithm in Bellman-Ford. Here, we use a synthetic random graph with 4 million vertices and 80 million edges. We build one master and 4 workers. Each worker has an exclusive GPU and a CPU core. Experiments on more workers are also completed and confirmed. Before running algorithms, the library should be updated and compiled in distributed environment. The updating script makes sure that the jar application and C++ library is available. We set the memory usage of executor and driver as 40 GB and 8 GB. The event log and history server file are enabled in order to analyze the resultant performance. We show our demonstration by running application through Spark Submit. We open the NVIDIA SMI to monitor the GPU memory usage and Spark Application Web UI to monitor the execution. In NVIDIA SMI we can see that the every worker node runs a computation server to process the graph data in GPU, and the consuming of GPU memory is acceptable. Now the algorithm executing is accomplished in GPUGraphX. We can see that the computation daemons in 4 workers are shut down. To compare the efficiency, we record the running time in every iteration and the result of algorithm for GPUGraphX and original GraphX. The log of GPUGraphX is shown on the left while the log of GraphX is on the right. The implementation of SSSPBF on GPUGraphX costs 1,188 seconds while on GraphX costs 1,397 seconds. We demonstrate the GPUGraphX runtime analyzer, with which users can browse and analyze the time logs in an interactive way. Overall tab shows the global statistics of iterations, of which the source data and trend of time that can be checked. We can also check the percentage of every step in runtime in overall tab. From the runtime percentage we can see that the computation time accounts for a large proportion. To check the details of computation, we can switch the tab to partition. The computation is composed of 3 sub-steps. Through Runtime Analyzer, we can investigate the time cost of sub-steps during computation, in the view of both partition and iteration. The Runtime Analyzer can also check the time logs of original GraphX by switching the source of data. The computation time of GPUGraphX is superimposed to that of GraphX. It can be observed that the peak time is reduced from 110 to 50. From the analyzer we can find that our system has a significant efficiency improvement over GraphX. We implement SSSPBF, label propagation and other algorithms to evaluate the performance. Similar improvement is observed for all testing cases. For example, for the label propagation on Wiki Topcats, GPUGraphX is 5 times faster than GraphX in total time, demonstrating the superiority of our system.